Okay, today we're going to talk about the fact that any context can have more than one ratio. That means that when you look at things, some are going to feel comfortable, some are not going to feel very comfortable at all. When we're looking at making these ratios, we can also convert them into unit rates. And again, some will feel comfortable because they're everyday occurrences. Some may not feel quite so comfortable, but still are just as useful. So we're going to look at making two possible unit rates for several situations today. Our first one is that a sandwich shop uses 24 slices of meat for every 6 sandwiches. Well, an easy way to draw a model is to kind of use the table idea that we have discussed earlier. When we're looking at a table, we're going to do two tables that actually represent this situation, and we're going to write a ratio for each one. We have slices of meat and we have sandwiches. So I'm going to put the category here of slices and sandwiches, and then on the other one I'm going to reverse that and put sandwiches and slices. Now when we look at this, we're just going to categorize each of our number values. It says 24 slices of meat. So under slices, I'm going to put 24 on each one of them, and 6 sandwiches, I'm going to put 6 under each one. When we are looking for a unit rate, we want our first column, or what's typically called our X value column, to be a 1. So I am going to put a 1 here, and we're going to find what goes with 1. Same thing over here, putting a 1. So that we can then set up a unit rate, because a unit rate is per 1 of something. When we look at this, it's based on what does it take to change that to that. Well, to get from 24 to 1, I simply can divide by 24. That means what I do to one side, I do to the other side. Very typical of things like fractions and equations and ratios. Because really, I could write this ratio in fraction form. When I do that, 6 divides by 24, that's kind of a little weird unless you think about it in its fraction form. 6/24, which would simplify to be 1/4. And that means that my unit rate would be 1/4 sandwich per slice of meat. Conversely, on this one, we are going to go from 6 to 1. To go from 6 to 1, I merely divide by 6. 24 is easily divided by 6 and is 4. That gives me my unit rate of 4 slices of meat per sandwich. Now for many of you, this one probably feels a little more comfortable, but yet both are valid. When we look at using these models to determine slices of meat that you will need for 5 sandwiches, that might be a little easier to use this ratio, because this is per sandwich and we're looking for 5 sandwiches. So to make this really, really simple, I take my ratio of 4 slices of meat per sandwich. And since I want 5 sandwiches, I can just multiply all of this by 5. When I multiply this all by 5, as in 5 sandwiches, what I end up getting is 20 slices of meat. That will give me 5 sandwiches, and 5 times 4, of course, is the 20 slices of meat. When you have a unit rate, it makes things quite simple to do. Here, we want to determine how many sandwiches you can make from 15 slices of meat. Again, in this case, I would want to use whatever I have for per slice of meat. Okay, so that would be using my other one. I know that I have 1/4 sandwich per slice of meat, and I can simply multiply it by the number of slices of meat. Since this is 1, I can times it by 15. When I do that, of course, I would need to put 15 over 1 so that I can multiply the numbers as fraction form. As I multiply that, that becomes 15/4, or we know that 15/4, when we simplify it, is 3 3/4. So my solution would be 3 3/4 sandwiches can be made from those 15 slices of meat. So even though they don't necessarily feel comfortable, they can be quite useful. Now we could use that one. It would be a little more work, and so that's why we look at what are really the 2 unit rates that we have. Feel free to pause the video, look at the work, maybe write down the problem at any given time. Meanwhile, going to move on to another situation. This situation, again, calls for 2 possible unit rates. What we are looking at is 3/4 of a cake to feed 1/3 of the class. Whoa, I know. We've got fractional amounts. That means it's going to be a little bit different, but still not all that awful because we know how to deal with fractions and we know how to get a fraction to be worth the value of 1. Again, I'm going to start out making my 2 tables. And what I have is cakes and a class. And over here, I'm just going to reverse those and write class and cakes. So when we look at this, I have 3/4 of a cake. So under cake, I'm going to write 3/4. Also over here. I have 1/3 of the class, 1/3, 1/3. Remember, to make it a unit rate, my first column needs to be 1. I need to now figure out what it takes to change 3/4 into 1. Well, that's easy. 3/4, if I multiply it by its reciprocal, which is 4/3, that would give me 12/12, which is 1. So what I do to one side, I'm going to do to the other side to get the other value. And that will give me 4/9. That means that 4/9 of the class per cake is my ratio. 4/9 of the class per cake. Pretty simple, even though it had fractions in it. Again, what does it take to make 1/3 become 1? Well, that's pretty easy. I just can multiply it by 3. Or, technically, 3 ones. What I do to one side, I'm going to do to the other side. What this then gives me is 9/4, but 9/4 I can simplify into being 2 1/4. So this unit rate would be 2 1/4 cakes per class. This then makes it very simple to find those unit rates. The table makes it easy. It's not the only method you can use, but it's probably one of the easiest methods to use, especially since we've already discussed about tables. This next question says, how many cakes will you need to feed 2 classes? Well, let's see. To get to 2 classes, do I want to start with 4/9 of the class? Probably not. Do I want to start with a whole class? That's probably my best. So I am going to use that 2 1/4 cakes per class, and I am then going to multiply it by 2. Now to get there, of course, 2 1/4, I really need it in its other form, which would be back to the 9/4, because I need to multiply it, and I'm going to put 2/1. When I multiply these, I can use cross-canceling, or if you want, you can just go ahead and multiply it. If you do, that would be 18/4. 18/4 simplifies out to be 4 2/4, or 4 1/2 cakes to feed 2 classes. Now, of course, some of you might be comfortable with saying, oh, well, 2 times 2 is 4, and 2 times a 4th cake would be a half. Regular, real world kind of situation. Whatever works. Fractions are real world. Get used to working with them. Oh, what percentage of the class will 1 cake feed? What percentage of the class will 1 cake feed? This one gets to be a little more dicey, but still not impossible. When we look at percents, remember percents are out of 100. And we want to know with 1 cake, 4/9 of the class. Well, we're really looking for an equivalent fraction. What we can do are some multiple things depending on your past experience in 6th grade. Now, one thing you could do is you could figure out how many 9s fit into 100. How many 9s fit into 100 is what you could multiply by. So 9 fits into 100 11 times. That's 99. And then I would have 1/9 left over. I know that's kind of a weird number to multiply by, but still not impossible. Then, if we multiply the top by the bottom, I'm going to multiply it by 11 1/9. And what I end up getting is 44 4/9. That means that I have 44 4/9% of the class are fed by 1 cake. Now, if you do this with a calculator, the only problem is you end up with a repeating decimal. That's okay though, because a repeating decimal here would be 44.44444444, which would round off to 44.4. Still equivalent ratio. All right, let's take a look at this last scenario. It says it takes 3 3/4 of a cake to feed 1 2/3 of a class. Is this proportional to the rate above? Well, we can look at this in multiple ways. We could do one of the models. We could figure out how much 3 3/4 cakes feed. Kind of a lot of variety. One of the easiest things is just do cakes and class and then see if it's equal to either one of those. So if I do this and I say that I have in cakes 3 3/4 and in a class, which is 1 2/3, I know that that's just not going to work too well unless they're in their improper fraction form. I am going to change them to be their improper fraction form. So 3 3/4 is really 15/4. 1 2/3 is actually 5/3. We want to see if changing those into one cake might make this be the same as either of those. So I am going to multiply by the reciprocal, which is 4/15, to give me 1. Over here, I'm also going to multiply by the reciprocal of 4/15. When I do that, I could end up with some cross canceling or just multiply. That would be 20 45ths. And if I divide both of those by 5, I'm going to get 4/9. Oh, hey, look at that. 1 to 4/9. 1 to 4/9. So is this proportional? I would say yes. It is proportional because they are equivalent ratios. Okay. So let's try another one. This one says, find the 2 possible unit rates for the given situation. We have each half hour a 3-dimensional printer prints 1/5 of a heart valve model. Okay, so we are going to do our 2 tables, and we're going to go with our time of hours, and we're going to go with the model. I could write heart valve model, but that would kind of be taking up a lot of space. Over here, I'm going to just replace one for the other. It says half an hour, so under my hours, I'm going to put 1/2, 1/5 of a heart valve. I'm going to put 1/5. And now, each of those I am going to change to 1. Well, to change a half into 1, we know we could just multiply it by 2. Over here, though, if I multiply it by 2, I really need to make it 2 ones so that it's fraction multiplied by fraction. And what I end up getting is 2/5. So this model then gives me 2/5 of a heart valve model per hour. Here, I'm going to multiply by 5. Over here, I'm going to change that to 5 ones. When I do this, I get 5 halves, which does simplify into being 2 1/2. So this would be 2½ hours per heart valve model. Piece of cake. Now, by the way, take a look at this. 2/5, 5/2. What? That's interesting. Back here, 4/9, 9/4. Oh my gosh. They are themselves reciprocals. Bet you didn't see that the first time around. So, it's kind of an interesting relationship. Well, let's take a look at this one. It says at the store, you can get 15 cans of peaches for $3. All right. We want to find the unit rate for $1 and the unit rate for 1 can. When it gives us this specific, we remember that we want to have the 1 in our first column. So if I want $1, that means this is the dollars, and this would be the cans. If I want it to be for 1 can, that means this needs to be 1, so this would be cans, and this would be dollars. Now remember, we are working with money, which will become a decimal. When we look at this, it says 15 cans, so I'm going to put 15, I'm going to put 15. For $3, $3. To change 3 into 1, I simply divide by 3. So that means I'm going to divide by 3 here, and I will get 5. So this unit rate will be 5 cans per $1. Here, however, I need to divide by 15. That means I need to divide this by 15. But remember, this is dollars. So this actually would be 3.00. When I divide that by 15, it's really pretty easy. You can do it on your calculator, or you could just draw a really fast little 3.00, divide by 15, raise your decimal. That's 0. 15 fits into 30 twice, which is 30. I bring down my other 0 because it is money after all, and money does need 2 places. The 15 divides into 0, 0 times. And so this time, I get 0.20, or 20 cents. However, we will want to write it, because it is in dollars, as 0.20, so no dollars and 20 cents, per can. There you have it. Those are our 2 unit rates involving money. We have just one last question. It says, how can you find a unit rate from a different point of view without drawing a model? What did I just point out? Oh yeah, if you have a unit rate, this is a neat thing. If you have a unit rate, the other unit rate is the reciprocal. What? Okay, so remember back, we pointed that out on a couple of them. And if you look back on the previous examples, they are all reciprocals of each other. That's it for this lesson. Hopefully It's easy. It should be, as long as you remember your reciprocals and their relationships. Feel free to go back, rewind, review, and if you still need some help, contact your teachers. Bye now.